Okay, so next presentation, Katarzyna will talk to us about techniques and insights into Kubernetes with limits with kinds, and I think this is actually a co-presentation, so I'll let her explain the details. So go ahead.
Yeah, hello. Hi, I'm Katarzyna. This is very loud. Can I? Okay, I hope it's fine. Hello, I'm Katarzyna. So I will be presenting Techniques Inside. This is a presentation that I was presenting on this year KubeCon on Maintainers Summit together with Antonio. Antonio, he's my colleague and he's co-chair with Sync Network, and he's kind of advocate for better testing. And in this presentation, we will focus on tests, and I will have some demo to present in practice how we can use kind to actually improve our testing or to do scale testing with Kubernetes. Starting from the beginnings, we can start what is the performance and what is the difference with the scalability. So we can say that performance, this is the efficiency of our system. This is how our system can handle resources like memory and RAM to perform some operation. And we measure performance in basically two ways. One is the latency. This is the time how our system can do the operation, for example, round trip or provision service. And throughput, this is the information that tells us how many of those operations can our system handle in given amount of time. And the scalability is our ability, our system to grow. So this is telling us how our system can maintain this performance, this efficiency and responsiveness when number of our users and operations and requests is growing. And Kubernetes is very complex system. We have so many different API, resources and dimension. And there is this term which is saying scalability envelope, which is showing us how this multi-dimensional environment can be visualized. Because when we want to test our system in terms of scalability, we need to find those thresholds. And when we have so many different APIs, and that when we are trying to maximize one API or one resource, it impacts others. This is very hard for us to do. And one good example is, for example, number of nodes and pods in the system, because their relation is based on the APIs and the networking. We cannot maximize the number of nodes and pods at the same time. One is impacting the other, and this is very important for us when we are trying to find the limits for our performance and those scalability thresholds. And how we should actually find them and test them. Kubernetes is the API-driven system. That means that we have so many things like nodes, pods. I mentioned this before, those APIs, and also we can have our custom resource definition, so we can add another APIs. But we as people who are building something on top of Kubernetes, or who are developing on Kubernetes, this is for us very important to make our system stable, to be confident how our system behaves in scale. So we need to have a good way how we should measure the scale or how should we test it. And testing should start from the development phase. So while we are developing the interfaces for our API, we should focus how it can be properly mock tested, that the other teams that are working on different API that can test their setup together with others. So this is very important. So how we should start it with our journey with scale testing or overall testing, we should make it simple. We shouldn't overcomplex our setup. We should start from breaking down the problems and truly understand what we are trying to achieve. We should isolate our problems. We should isolate our API from different APIs. And also we should isolate the API from the hardware, because this is very hard to provide stable tests when we are actually depending on hardware. And of course, we need to have very deep understanding in this complex system like Kubernetes, because this is very important for us to maintain our test grid and to have good understanding on the results, for example, from our scale or performance test. And there's a good list from Brennan Gregg, who's been working in Intel and network, and he's focusing what we should not to do. There's this anti-methodology list, which might sound funny, like for example, that we shouldn't blame someone else, or we shouldn't act as a drunk man and introducing some random changes. But actually, we can say that when we are having the problem which is overwhelming us, like for example, we have too complex tests, we have too complex system, we are trying to find this one golden solution that will actually make our problem disappear. Like for example, routing this back to other teams, or for example, finding some logs from other components and pinpointing to there, or like direct methodology, which is like manipulating some attributes, or for example, increasing some latency pooling to actually make our test to pass. And or another example is to actually doing some benchmarking or some other profiling from well-known tools, but actually without those deep understanding and trying to deep understanding of the tooling, or actually the metrics that we are and attributes that we are testing and using. And of course, the last one, traffic lights, which is saying that if we have our pipeline and everything is green, that we are good to go, and we can we are good to go and we can ship. We should also be careful that we need to make sure that quality of our testing of our pipeline is good, because our software, our product is good enough as just like our tests. How we are confident with this, just like our tests are good. So here comes Kind. Kind, this is a Kubernetes-in-Docker. This is a product which was invented to actually test Kubernetes. It uses Docker to simulate nodes, so we can actually set up Kubernetes on one machine without actually having those heavy-duty nodes or other system and working with all of those stuff like networking. Of course, Kubernetes will never replace a real cluster, real testing setup. It should be one of the steps in our pipeline, and I think it should be every Kubernetes developer best friend for smoke testing, for testing things manually, and of course it can be used in CI. And I prepared two real case studies that to demonstrate how we can use Kind to break down some real problems. First, the problem was the bug in Golang. So the test was that we've been having this large-scale AI ML jobs that we've been having. We wanted to introduce a cluster which was that has more than 5,000 nodes, and we've been using headless services for service discovery. It turns out that actually in Golang resolver there is this bug. So starting from the beginning is like in Kubernetes we have the in-cluster DNS, which is creating the DNS records for every services. For headless services, it creates the record which contains all of the IPs from all of the pods. We wanted to do the service discovery, so we wanted to do 1 pod per node, and this way discovers how many we have pods and what are the IP addresses of those, how many nodes we have in the system and what are the IP addresses of the nodes. And it turns out that the DNS, when the response message is too big and it doesn't fit in one packet, it is setting truncated bit, and it expects that the client will wait for another part of the responses. And in Golang version 1.22, I think, there was the bug that the truncated bit was mishandled, and it resolved with the failure with DNS resolution. How we approach, how we tested this issue, we we split the problem into pieces, and we know that how to use Kubernetes API to actually emulate so many nodes or even pods, right? We wanted to create DNS records which will contain so many IPs, and we knew that for headless services, the Kube API is using endpoint slices for headless services to find all of the IPs. So we didn't really need it to create the kind with so many nodes, which are, containers in Docker, but still this is very heavy. We didn't really need it to create also some additional pods. We just created fake endpoint slice object, and this triggered DNS records creation. Okay, and I can switch to the demo. This should be the one. Okay, we don't really have a lot of time, I see. So overall, this is very lightweight. You can see that this is the config for creating cluster. With we're just using create cluster, and we can also configure more things, but I think that overall this is very lightweight. And we can see that I created the cluster with a few workers, and there is one also node with control plane where actually some controllers are working. For this problem, I created some huge service. This is a one service, headless service, and I created fake endpoint slices to actually generate the IPs. So the core DNS, which I'm using as my in-cluster DNS, will generate the DNSA records for me. Here I show the core DNS. So core DNS, this is like I said, this is the DNS that I will be using, and I wanted to. When I was sending my DNS queries, I wanted to use the IP address of the core DNS to make sure that actually I'm asking the right DNS, and there is no problem with some network configuration. Another thing, how can I query DNS in this cluster? I use pod for this, and I spin up some DNS client pod where I have some image with basic Linux tools, like for example Dick, so I can use for DNS name resolution. In Kubernetes, there is some convention how we build FQDN for services, which is like service name and namespace, and there's this suffix service cluster local. And here we can say when I send it directly using Dick, so this is basically using libc under the hood, the DNS resolution works. We have more than 4,000 records for this service. But I wanted to do this in Golang, so I can create a test in Golang. So I prepared some image in the Golang, and I used Dockerfile to actually build this image. And then, when I built this image, I wanted to use this image in my kind. This is very easy to do with kind. Why it's not? Why it stopped? This is very easy to use with kind because there is kind load command, which can copy your image from Docker repository. And because the nodes in the kind are the Docker container, we can use Docker API to actually access to this node. So I just exec to the node to print all of the images that I have on the Docker. And one important thing is that you can see that my image, which is DNSStat, it started with Docker IO library. I think that this is important because I built the DNSStats and the tag image, and here the full image name or path is different. And this is important because when I want to use this image actually to spin up and pod in my kind cluster, I need to use this full path. Otherwise, it won't be resolved. And another important thing is that we shouldn't use latest stack with kind, because latest stack is telling the system to always pull newer image from the repository. But actually this image was downloaded, right? There is no repository that actually the image can be pulled, and it will result with pull image error. So you can see that I run this pod, and there are problem with DNS resolution, which is odd, right? Because before I show you that actually those records are present in the core DNS, and I can again run another different command like nslookup, and you can see that the name resolution is working. So this test is proving that actually there is the bug in Go 1.22 library, and actually thanks to Antonio the bug was fixed in next version. And I prepare also the image with version Go 1.23, and here you can run it and demonstrate that actually it is working. So this is one real-world example, and we can see that we are running a little bit out of time. No, we have plenty of time. Okay, so another real-world example is kubeproxy performance. kubeproxy, this is on-node controller, which is responsible for programming data path in Kubernetes, and mostly is responsible for creating the rules for service to pod discovery. And also with high-scale kubeproxy, previously kubeproxy was used with IP tables. IP tables were used to create those rules to show the routing rules. But it turns out that with high-scale kubeproxy is based of IP table is not working well. This is mainly because the IP tables has linear search and introduce lock while the rules are inserted or deleted, and it impacts all of the operation on the IP tables and also the routing. So based on those observations, the community moved to using NF tables as a tool to program the data path for kubeproxy. And in this example, I wanted to show how we can measure the performance for kubeproxy using the kind. And in this example, also we will use the information that we don't really need to spin up so many pods, that we can only generate the number of IPs in endpoint slices. This time I will use cluster IP service because I want to create this routing table for service to pod discovery. And I have another example, which should be here. Okay. And in this example, I'm creating client cluster, but you can see that I passed it image version. I wanted to create another image version because this one is based on the IP table is a default, tool for programming data path. What I'm doing here, I want to show you how we can use the observability. kubeproxy is on-node component. It is installed as a daemon set, and it's using config map for different configuration. So if you want to enable logging or metrics, we need to introduce some changes in this file. For example, increase the verbosity or add some binding address to this config map. And because the config map is read at the startup, so we need to actually restart the DNS kubeproxy daemon set using this rollout restart command. Another thing is that I set up the Prometheus to export my metrics, and Prometheus will be is installed here as a node port, as you can see here, and yeah, I wanted to show here how we can actually use metrics. This is like, let's say, extra metrics when we are working with the remote setup. I, for example, personally, I have this very small Mac, and I'm using the remote machine for my actually development, but I really like using a web browser on my Mac. So what can I do? I can just forward the port that actually my remote machine, which I'm connected with, I can forward the port where those where this Prometheus service is exported using node port. This is the port, so I can be able to actually using localhost and this port that actually I forwarded or binded. I can use this to access the metrics and the dashboard from or the dashboard from the Prometheus. This is very useful because Kubernetes has a lot of metrics exported, and we should use them during our development. Okay, here I splitted my tmax, and here we can see the top. So this is, we will be looking what's going on the node, what is the resource consumption, while our Kubernetes is programming the data path. So I created some script, a Go file, which is creating endpoint slice with so many endpoints for one service, and we will see how it's impacting our data path. As you can see, at the very top, there is the IP tables restore process, which was consuming 100% CPU, it's consuming a lot of CPU. But my endpoints, those are fake endpoints. There is no pod application behind this, and I wanted to test how is behaving my data path is programmed, how this is behaving. So I created this service web. This is a real application with some Nginx, and I expect that when I create this service, my data path for this newly OnePlus service added will be programmed instantly, and I can access this. So I want to run some benchmark to, for example, using Apache to see how it is behaving. And as you can see, it is waiting. So there is no actually routing, there is no traffic, is not accessing our pod. And here we can see this is the UI for the Prometheus. I exported the port so I can access this from my Mac. And you can see this is kubeproxy1 metrics, which is saying IP tables total. So it's telling us how many IP tables has been created. So there is a lot, but more than 10K IP tables rules. And another metric which is important is the latency. This is duration bucket, seconds bucket. As you can see, there was some missing line. So there was some time that exported, and then there was some missing metrics. That means that our process is still processing. As you can see, IP tables restore process is still eating 100% of our CPU, and it's not finished yet. We can also take a look at the kubeproxy logs because we enabled them, so we can see what's going on in the kubeproxy. As you can see, the last line is saying reloading service, and it was a few minutes ago. And this process is still ongoing and eating our CPU. And another good thing with the kind is that we can actually switch between clusters easily without impacting work on the cluster from one on each other. So I can actually switch to the cluster which I created before for showing NFS, how to use NF tables with kubeproxy. And at the beginning, I should say that when we are using kind, we can also by default use kubectl, all of those tools that we are using with our regular Kubernetes cluster, because this is still Kubernetes cluster, right? And this is the manifest for creating the cluster. And to enable NF tables, we have some feature guides that we need to enable, and we have some configuration that we don't really need to do those hacks that after cluster creation we are doing some extra stuff like enabling lock. We can do this at the cluster creation, but also there's an option to enable this later. So this is the manifest how we can actually configure kubeproxy with NF table. And I will run the same script, the same mechanism to show you what is the difference in the behavior when we are working with NF table. And also I will exec to the node to see what processes are invoked and how it behaves. Okay, so yeah, I started to create a lot of endpoints, and we can see that at the top we have NFT process that has been started, and it's eating some CPU, but it's but after some time the process is eating less CPU, and then it's like it's finished. And I will also spin up a new pod with some real pod with some web application to see if the data path for it has been programmed and how it behaves. And this is I run this benchmarking. As you can see, there is some traffic, and actually this for NF table, this is working. Okay. Okay, so to sum up, testing is very important to be confident about our system and how we can use it. We should be aware of our thresholds and limitations for our system. How we can achieve that is by investing in our scale tests. We need to deep dive into the problem that we want to solve, and we should go with the simplicity. And Kind is a good tool because this is simple and it allows us to isolate the problem and emulate other, let's say, components. I guess that's all. Any questions? That was a lot.
Yes.
Yeah, it's a bit narrow, but I was just wondering, so basically if you do like have a couple of operators like additional on the Kubernetes itself, does it actually is use case for Kind or probably not for tested
Can you
properly?
repeat, because you were saying can you take it louder, because I'm not...
Yeah, so I was asking if we have multiple operators and we want to test like different custom sources, we also can do it with Kind, right? So they are communicating properly, like in Kubernetes it would be allowed.
Yes, when you are running the operator, basically you usually run the operator as a pod, right?
Yes.
So you can run the operators as a pod. You need to bear in mind that you have the limitation related to your machine, right? The memory and the RAM, basically. So if your operator are not that heavy duty and you can abstract other things from this operator, that it doesn't really depend on other real pods, then yes, this is a really good tool for testing your operators.
Okay, then sounds good. Thank you.
Yeah, thank you for the presentation. So basically for our cluster, in our project, what we are doing, we are developing EKS clusters, and we have over, I would say, like 30 add-ons, which we also managed ourselves. My question is that now we are looking for ways, because when we are doing the tests, we are waiting for our pipeline for 1 hour to create a transient cluster and then test our add-on, whichever is there, even just simple bump up. So my question is, do you think Kind is good for testing such clusters? Because sometimes one add-on is dependent on another one. And if I want to do like a very quick cluster creation, probably I will need to, to test one add-on, I will need to add others as well. So is Kind good for such testing, or you would recommend something else?
I would say that it depends. I started from this Kubernetes envelope. There are some dimensions that we can see that they impact each other. So you need to understand how other add-ons are impacting your thing, right? You usually want to first test something in isolations to see limits with your API. And then you need to evolve and create other tests to make the full picture. I think that when you, I don't know if you have been designing the add-ons or they are, shipping out of the box, but I also mentioned that this is good while designing or working on the products to think how it can be tested or how can it be used. And for example, when you have some add-ons and you know that how it will impact with you can still mock this or emulate this add-on, But with your mock, you can, the dimensions that are crossing each other, the things that impacting each other, you can then still in this mock you can use. For example, with this API, right, that we are creating the endpoint slide API, and we are from the kubeproxy API, we are detaching the information that there are real pods. They are not needed here, right? And the pods are eating our resources, and this is the time provisioning the pods. This is, let's say, this time that your test is waiting, for example, when they are ready. Similar issues with networking, that sometimes you are waiting for your CNI to be ready to create all of those rules for service resolution. So if you can detach those things from your add-on and simulate them or fake them, I think that you can use kind and cut some time from your test. But also, I mentioned that this is one of these, let's say, layer in your pipeline, that kind will never replace the real life test, but you can shape your CI this way that you can run this lightweight test more often, like a few times a day or daily, and once a week run those scale or some of these heavy duty tests.
Thank you.
Thank you. There are a couple of ways of running clusters locally. There's K3D, Minikube, Kind. So I'm curious, could you do that with others? What were the reasons for choosing Kind in particular?
Oh yeah, this is a tricky one because I'm kind of a user of this kind. You know, I can tell you that only from history that we've been struggling with maintaining in Kubernetes, with maintaining our test infrastructure stable. There were a lot of flags, and I think that the kind was the project that was evolving and learning from all of those mistakes. And with kind, we've been cutting some, let's say, painful issue, like for example with this networking that we are waiting for CNI to be ready for our use. And I think that it's not like ideal that I think that the different solutions might be for different problems, but for us, when we've been testing, we want to test Kubernetes, and in fact we want to test the API because there are some other cloud providers which are adding very different implementations. So it wasn't very, for us, the importance was how the API, how our Kubernetes controllers are performing in tests. And yeah, I think that this is one of the way. And the reason why I recommend this way is that because we can focus on the API and test some small controllers and their relation between we don't have to very focus on the networking, for example, or hardware.
Right. Thank you very much.
I have a question about NF tables and proxy.
Another tricky one.
Yeah. So, have you tried running this with kubeproxy replacement?
With kubeproxy replacement?
Kubeproxy replacement is an actual thing called
the Cilium, you mean the kubeproxy? No, so actually kubeproxy replacement Cilium, this is actually for kubeproxy only. This was before actually Cilium was in place. And this is, I mean, we wanted to demonstrate how, you know, the OSS community evolved from IP tables to NF table. Cilium, this is another let's say solution for response of IP tables bad performance, but eBPF also has some limitations. Yeah, but right, yeah. Thanks.
I mean, since I already have it, I have a second one.
Okay.
So,
yeah.
Is it possible with Kind to operate different container CSIs, so container storage interfaces?
I don't know. I know that with Kind you can run Cilium with Kind. If this was your questions, yeah, you can run.
Right now, I'm asking about storage.
Yeah, Cilium is actually using Kind in their CI, I guess. I know that they are testing with the Kind, but storage, I don't know. I'm sorry.
Come on, guys. This doesn't bite. Ask questions.
Anyone?
Yeah, we have like 50 seconds. Okay.
Any quick question? Okay, then I guess if not, then thank you, Katarzyna.
Thank you.
And just a quick announcement will be. So we'll be doing the farewells in 10 minutes in hall, in the big meeting room where we had where the conference started. So hopefully I'll see you all there. Thank you.